going to talk about a really exciting project, essentially how to build a highly secure and available internet and network layer for the Sui ecosystem. So this is called Sui HyperNet, and the slide says highly secure and available network fabric for communication. So if you look at the Sui ecosystem, we have a lot of exciting technology. We have, of course, Sui itself providing compute and providing transactions, and Walrus providing the storage. And now with Sui HyperNet, this also provides the network and the communication. A lot of ecosystems have such aspects. However, in the Sui ecosystem, the distinguishing feature is really to achieve very high levels of security, and that the entire system is designed with security in mind to defend against active adversaries. So also the system, the whole ecosystem, all the components provide high integrity, high availability, and also what's very exciting, and this is a new initiative, to provide quality of service guarantees for many aspects of the whole ecosystem. So I'm going to talk more about the quality of service aspects in the network and the Sui HyperNet in this talk. So this is super exciting because these are all very hard and challenging problems to achieve, and so hope you're also excited about these aspects. So hope it's obvious, but networking is absolutely fundamental for Web3, for the whole decentralized ecosystem, right? Without networking, a decentralized ecosystem cannot work. So this is similar to a fish tank without the water, right? Without the water, it's a bit difficult for the fish to swim around, right? So with Sui HyperNet, we have the water that provides our ability to operate. And so let's dive in to see how this can work. Some of you may think, well, we have a lot of current technologies that already provide connectivity. We have the internet, we have VPNs, we have private networks, but unfortunately, there's a lot of issues with these technologies. So the internet, for instance, is quite brittle. So in the presence of active adversaries, it's difficult to achieve highly resilient communication on traditional internet technologies. Also on the internet, we cannot achieve strong quality of service properties. And also, we don't have strong defenses against routing attacks, and as well as the distributed denial of service attacks. We can also make use of VPN overlays, and of course here we get some additional resilience by being able to have different entities one can connect to. But fundamentally, VPNs are also built on the internet, and so we inherit a lot of the same challenges and drawbacks that the internet has. Also, with VPNs, we cannot achieve strong quality of service guarantees. So people say, well, let's use private networks, but private networks are expensive and very difficult to operate in a large decentralized environment, right? It cannot scale with the dynamic nature of Web3. So to solve these challenges, we introduce Sui HyperNet. So it's a secure connectivity layer for the whole Sui ecosystem. And it's robust to routing attacks with built-in distributed denial of service defenses. And the component providing quality of service is called Hummingbird. It's been designed by researchers at Misten Labs. And Hummingbird provides a quality of service layer with strong network guarantees on a public internet ecosystem. So these properties are possible through the Scion protocol. Andrew was also just talking about this with Carrier 1 offering Scion connectivity. So this is a network protocol that we've also been working on for the past 15 years, actually. And so let me give you a bit more background on that. So the Scion protocol is a secure next-generation internet that you can use today. It's an alternative to today's BGP protocol used in today's internet. And it provides secure connectivity on a public infrastructure network. So it's not a private network, it's not a closed network. it really is based on, similar to today's internet, ISPs offering the protocol and interconnecting with each other. Cyan is highly secure and robust to BGP routing protocol attacks and has built-in defenses against DDoS attacks, offers high flexibility and high availability. So the system went in production in 2017, so it's already been used and tried for critical infrastructures. So if you look at, given all this, we can see an exciting intermediate-term vision where Sui HyperNet can provide secure and highly available connectivity for the whole Sui ecosystem. And vice versa, Sui can be used and can provide as a coordination layer for instance, the quality of service properties on Sui HyperNet. So let me briefly tell you how this can be deployed. So here is one example of a deployment model we've been using for this. And here we see the example of a validator node, where we're adding connectivity to a device called the edge device that is typically running in the same data center, and that then connects to this Sui HyperNet network, which also connects to the broader Cyan network. So to interact with this, we use a routing daemon called FRR, an open source system that manages the routing tables in the kernel. And so we then see that the validator software can then, if Sui HyperNet is available, make use of this network and transparently switch back and forth with the internet and with the Sui Hyper network. So essentially, the exciting property is that we can obtain connectivity as long as either Sui HyperNet or the internet provides this connectivity. So what's exciting is if there's, for instance, internet attacks, the system can switch over and then still provide connectivity and operation. So the current status is that this is operational on testnet. So we have a number of entities already connected to this, including validators, state sync full nodes, RPC servers, and so on. And since last week, also 2 Walrus servers that connect via this network. So here a bit more detail. Maybe you can remember from the talk at Paris Basecamp that we've been working on this since then. And so recently we've been relaunching this with a new deployment model that greatly simplifies how this network works. And we continue to expand the footprint with now also Node Infra, Artifact, Ruby nodes, and also Carrier 1 connecting to this network. And with a number of different places in the world, and here we see this a bit better, where these nodes are at, with Carrier 1, as we just seen, in Toronto and also in London, providing this level of connectivity. So I hope you're interested in participating in this project. So there's a contact form that you can fill in to meet with us. And so essentially, if you're a Sui community node operator, and you're looking for more resilient network connectivity, please come talk to us. Also, if you're a community infrastructure operator and provides, for instance, bare metal nodes, cloud, or SaaS services on Sui, and you'd like to provide premium network connectivity for Sui offerings, also please come talk to us. So with this, Abhinav and I are here. John unfortunately couldn't make it all the way to Dubai. But again, please fill in the contact form if you're interested. Looking forward to talking with you more in detail and seeing how to get you connected. Thank you very much.